Hi everybody, welcome to my channel. Today we're going to talk about the vertex form of a quadratic. So the vertex form of a quadratic is one of three major forms of a quadratic. The most common form is standard form, which is ax squared plus bx plus c. The second form of a quadratic that we've talked about already is factored form. That's where we take the standard form and we factor it into two binomials that we can then use to solve for the x-intercepts. The vertex form of the quadratic, unsurprisingly, highlights the vertex or the tippy top or very bottom point of that parabola that makes a quadratic, the parabola being that U shape that makes a quadratic. So this is the vertex form of a quadratic. F of x equals a times parentheses x minus h squared plus k. We've talked about this a value before when we talked about the standard form. The a value of a quadratic always serves the same function. If a is greater than 1, the graph gets narrow. If a is between 1 and 0, the graph gets wide. And if a is negative, the graph reflects vertically over the x-axis. That means that it flips over and opens downward as opposed to being U-shaped opening upwards. The other important parts of the vertex form of a quadratic are this h and k. H and k represent the vertex, so that point on the tippy top or the very, very bottom of the parabola. The trick with this vertex is that because this is minus h, whatever the value is for h, the vertex coordinate is going to have the opposite x value. So if this says minus 2, the vertex form for h will be a positive 2. If this says plus 3, the x-coordinate in the vertex form will be a negative 3. H also represents the horizontal shift of the function, and k represents the vertical shift. A horizontal shift is how much the parabola moves right and left. The vertical shift is how much the parabola moves up and down. When we talk about these shifts, we are talking about a shift from the parent function. The parent function is the most basic version of a specific function. In this case, the parent function for a quadratic is f of x equals x squared. In this parent function, the vertex is at 0, 0. It's opening upwards because it's not negative, and it's not particularly wide or particularly narrow. It's just a regular quadratic, and it will look approximately like this. This is the parent function of a quadratic. When we are talking about horizontal shifts and vertical shifts, we are talking about moving this quadratic function to the right and left, or up or down. Let's look at some examples. So in example 1, we have the function f of x equals x minus 1 squared minus 3. We're going to start by identifying the vertex. The vertex is our h and k values. Remember, we always, because of the minus sign in our function, have to change the sign of that h value. So here, my vertex is my h value is minus 1. So my vertex is going to be positive 1. And my k value is negative 3. That one does not change. So our vertex is at 1, negative 3. And when we transform from the parent function, we're going to use this vertex to help us figure out where we're moving. Because our parent function has the vertex of 0, 0, we are moving 1 unit on the x-axis. So we are moving 1 unit right. And then we're moving to negative 3 on the y-axis. So we are moving down 3. Let's look at example 2. Here we have f of x equals 2 times x plus 2 squared. Here, our h value looks like it's 2, but we have to flip the sign so it's negative 2. And then there's no k value here. So if we wanted to add in a k value, we could imagine that we are adding 0 at the end of this function. So our vertex is actually going to be at -2, 0. Our transformation of this function, let's start with our a value. Our a value is positive, so it's not going to flip, but it is greater than 1. It's 2. So that means that our function is going to get narrow. And then because our vertex is at -2, 0, we know that our function moved left 2 units. Now let's go down and look at our final example. F of x equals -1/2 x squared plus 2. Here, there's no parentheses, so there's no h value. That means h must be 0. There is a plus 2, however, so our k value will be 2. Our vertex is 0, 2. For a transformation, let's start by looking at the a value, which is -1/2. The negative sign tells us that our function is going to flip vertically, so it's going to have a vertical reflection. 1/2 tells us it's going to get wider, so it's going to be flipped over and wide. And our vertex tells us that we're going to shift up 2. So it's wide, it reflects vertically, and it shifts up 2 units. I hope this was helpful. Feel free to leave comments below. Looking forward to our next video.